Alright, let's dive into something mind-bending today. Have you ever stopped to think about how a beam of light can essentially cross the entire universe in no time at all? I mean, it sounds like something out of a sci-fi novel, but it's rooted in hard physics. Personally, I think this is one of the most fascinating aspects of special relativity, and it really challenges our intuition about time and space. What makes this really interesting is that while a photon travels a billion light-years from our perspective, it experiences zero elapsed time. Zero. As in, it doesn't age, it doesn't feel the journey, it just is. This raises a deeper question. If time is so relative, what does that mean for our understanding of the universe? From my perspective, this idea flips the script on how we think about time. We often imagine time as this universal clock ticking away for everyone equally, but that's just not the case. Time is deeply personal. It depends on your speed, your location, and the path you take through space-time. One thing that immediately stands out is how this ties into time dilation. You've probably heard about those experiments with atomic clocks, right? Where one clock stays on Earth and the other takes a trip on a fast aircraft. When they reunite, the traveling clock is behind. It's not just a theoretical concept, it's been proven. What many people don't realize is that this isn't just a quirky physics experiment, it's the foundation for how GPS works. Without accounting for time dilation, our GPS systems would be useless within hours. Now, let's talk about light itself. Light doesn't play by the same rules as everything else. If you throw a ball from a moving car, its speed adds to the car's speed. That's intuitive. But light? Nope. Whether you're standing still or zooming in a rocket, light always travels at about 299,792 kilometers per second. Einstein made this the cornerstone of special relativity, and it's why observers in different frames of reference can't agree on both distance and time simultaneously. This isn't just a cool fact, it's a fundamental truth about the universe. A detail I find fascinating is the concept of a light clock. Imagine two mirrors with a light pulse bouncing between them. When the clock is at rest, the light travels straight up and down. But if the clock is moving, the light takes a diagonal path because the mirrors are sliding sideways. That diagonal path is longer, but since light speed can't change, the clock ticks more slowly. This isn't just a thought experiment, it's a visual way to understand how space-time geometry affects time itself. What this really suggests is that time isn't a fixed backdrop, it's woven into the fabric of space-time. Hermann Minkowski's idea of space-time as a four-dimensional structure was revolutionary. It's not just space over here and time over there, they're inseparable. And when you move faster through space, you move slower through time. It's like the universe is balancing its books. Now, let's zoom out for a second. If you take a step back and think about it, photons are the ultimate travelers. They cross the universe without aging, without experiencing time. But here's the kicker. This doesn't mean photons are conscious or aware. It's a mathematical truth, not a philosophical one. Photons follow what physicists call null paths, where proper time, the time experienced by the object itself, is zero. This is why a photon can travel a billion light-years in what feels like an instant to it. This brings me to another point, curved spacetime. Einstein's general relativity tells us that massive objects bend spacetime, and light follows those curves. This is why we see gravitational lensing, light bending around massive objects like galaxies. But even in curved spacetime, the proper time for a photon remains zero. It's like the universe has this unbreakable rule: light doesn't experience time. In my opinion, this is where things get truly profound. Time isn't universal, it's personal. Every object, every particle, experiences time differently based on its journey through space-time. And light? Light is the boundary. It's the edge of cause and effect, the limit of what's possible. Nothing with mass can reach that boundary, and nothing can cross it faster than light. So, what's the takeaway here? Personally, I think it's this. Time isn't what we think it is. It's not a river flowing uniformly for everyone. It's more like a tapestry, woven differently for each of us. And light? Light is the thread that ties it all together, reminding us that the universe is far stranger and more beautiful than we could ever imagine. What do you think? Does this change how you view time and space? Let me know in the comments below. And if you found this fascinating, hit that like button and subscribe for more mind-bending science. Until next time, keep questioning, keep exploring, and remember, time is weirder than you think.